Okay, here we are, extension for 4.4, solving linear equations by graphing. So what we're going to learn is that when we have an equation with variables on both sides, with the x on both sides, right, we can actually look at each half of that, each side of that, and turn it into a slope-intercept form, or y is equal to, ax plus b, or mx plus b kind of a thing, and graph it. And where the two lines intersect, the x value of that ordered pair would be the x solution to this equation. Okay, so let's see what I mean by that. So here we have x minus 2 is equal to negative 1/2 x plus 1. We're going to use a graph. So first, this red one, x minus 2. So we start here. We have a slope of 1. You just kind of draw your line. Here we have a positive 1, and then we have a negative 1/2. They intersect at the point 2, 0. So that is like saying that x is equal to 2. Okay, and it is, if you were to solve it the way that you solved it in chapter 1. So we are going to do a few of these. So let's take a look. Let's see. Let's do number 2. I'll put that right here. And I know you don't have graphs on yours, so if you want to get graph paper and maybe make tiny grids, cut it out, tape it on, make it a little cut and paste activity, you can. So we have the two equations for number 2 are, we have y is equal to 2x, and we have y is equal to x minus 3. Okay, so if I have 2x, I'm going to go up 2 over 1, 2 over 1, same as I can go down 2 and back 1. Well, that's not down 2. Sorry. Okay, so this would be the line for the y is equal to 2x. Now, I am going to change colors for this one, y equals x minus 3, so you can see it a little better. So if I'm doing this, I have up 1 over 1, 1 over 1. I also have down 1, back 1. Okay. So it looks like all right. So the two lines intersect right here at this point right here. So this line, I probably needed to go down a little bit more, but that's okay. So that is at -3 and -6, right? So first, let me do this. The blue line is y equals x minus 3. So here's the point where they intersect, and that is at -3 comma -6, which makes x equal to -3 for equation number 2. Okay, you could try it out. You could try 2 times -3 is equal to -3 minus 3, and you get -6 is equal to -6, and you know it works. All right, let's do number 3, and we're going to have y is equal to 3x plus 1, and y is equal to 3x plus 2. So you can probably already tell these are parallel lines, right? So there will be no solution. So the purple line right here and it's a pretty steep line here. It's supposed to be straight. Only I could perfect that. I'll go back to the green line. Oh, this is my y is equal to 3x plus 2. Go back to my green line. And then that is 3x plus 1. They're pretty close together. 1, 2, 3. 1, 1. All right. They run parallel to each other, but they never touch. Okay? And the green line is y is equal to 3x plus 1, and no solution. They are parallel, they will never intersect. All right. Let's try one more. Number 6. Let's get me out of the way over here. All right, for number 6, we are working with y is equal to a negative 2x plus 3, and y is equal to negative 2x plus 3. So what do you notice about these? They're exactly the same, right? So this is an infinitely many situation. So down to okay, so my pink line looks like this. Oh my Lord. That's so crazy, isn't it? All right, so this is y is equal to negative 2x plus 3. Go back to blue. And then 1, 2 over 1, 1, 2, 1. Oh my Lord. You guys. 1, 2. Oh, this is terrible. Okay, my graphing skills while working on this little tablet are horrendous. All right, I apologize for that. All right, but anyway, it's the same line. Okay, so what do we have? We have infinitely, oh, I can't even spell, infinitely, many solutions, because it is the same line, so that could happen. But again, usually by inspection, you'll be able to tell that, and I'm totally fine with that. I'm going to go ahead and clear, so we're ready to move on. All right, I'm going to move me back down to the corner, get out of the way. Plant A grows 0.4 inches per month. Plant B grows 3 times as fast. And you can see the heights. It looks like plant A is 12 and maybe plant B is 9. So I had written this equation. So what we're looking for is after how many months are they the same height? We want to know how many months it'll be before they're the same height. So I have, 0.4 x for plant A plus the 12 that it started with is equal to, and then I do 3 times this, which is 1.2x plus the 9 inches that it started with. Okay, now I did a little something. I'm going to move this again. I should have kept it up there. I used a graphing calculator because of the decimals, and I used Desmos to do this because we don't have the use of graphing calculators here at the middle school, because our x value is going to be a decimal, and I'm like, I'm not going to do that on a graph for you guys, but x is 3.75, so it is after 3.75 months that they are the same height, and that's how you can do that. So when you're having decimals, you can possibly, check your work doing that. I wanted to show you that technology. And then also we're ready to go on to the next slide. So I am gonna clear. Here, I can tell you right now, every single answer is a decimal. So we're not gonna graph these. We're gonna solve them just like we did in chapter 1. So we can subtract x, 5x minus 2 is equal to 11, plus 2 plus 2, 5x is equal to 13, divide by 5, and x is equal to 2.6. So notice why I would not want to graph that. or you could put them on a graphing calculator and practice with Desmos. Okay. I want you to do number 10. Go ahead and work number 10 out since we don't have a vocabulary and concept check. Pause the video, work that out, or graph it on Desmos if you like. Hopefully you got that x was equal to negative 20.5. Okay, so have a great day. If you have any questions about this, please put them in the question box. All right, and I will see you in class tomorrow.